So the short truth table method is an ideal technique for checking arguments for validity. The reason for that is because if you recall, what we're doing when we're checking an argument for validity is we're trying to find a counterexample. We're trying to see if there's a truth value assignment or a row of the truth table that is going to make all of the premises true and the conclusion false at the same time. And a lot of the times we can do that directly by just making one row of the truth table and seeing if there's any way that we can make all of these true and this false. And so we start trying to do that, and we fill in the left side of the truth table as we go and see what the results are. That's a little bit easier to demonstrate than it is to actually explain. So I'm just going to go through a couple examples. A lot of the time this takes a little bit of trial and error. It takes a little bit of going back and forth and erasing, which is why I encourage you to do this in pencil. But it's a really good technique, and a lot of the times it's necessary because you may have too many atomic letters in your argument to actually check in a practical way with a full truth table. Like both of these arguments use 4 atomic letters. That would require a 16-line truth table, which I don't really want to do. So let's take a look at this first one. It says P and Q, if Q then S, R is equivalent to QRS, there's a biconditional there, therefore if R then Q. I don't really have any intuitions about whether that's valid or not by looking at it. So let's go ahead and take a look here and see what this tells us. So we want to start not necessarily with the conclusion, but with the sentence that's going to constrain the possible truth value assignments the most in terms of finding a counterexample. Here it happens to be the conclusion, because remember, a counterexample, the conclusion has to be false. And there's only one way that a conditional can be false. Remember, it's if the antecedent is true and the conclusion is false. So we can go ahead and mark R as true and Q as false, because that has to be the case if this conclusion is going to be false. And so we can start checking these premises and seeing if they can be true. They can all be true given this. Right away we run into a problem. If Q is false, so is P and Q, right? So it doesn't look like there's any way that these can be true and this can be false. So we've already established that there is no counterexample to this argument, and it's a valid argument. We're done, okay? Now, how about this one? If R then P, if R then Q, S is materially biconditional with R, therefore P and Q. Again, that's one I don't really know by looking at it. I don't have any intuition about whether this is valid or not. Okay, so let's go down here and check this this short truth table and see if we can figure it out. So here we actually don't want to start with the conclusion. To make this false, there's a lot of ways P and Q can be false. Remember, that's false on 3 out of 4 lines of the truth table. Here, I think it's better to start with with S, because obviously there's only one way this atomic sentence S can be true, and if that's if S is true. And that tells us that R must be true as well in order to make this biconditional true, because remember, a biconditional is only true where both letters are either true or false together. So if S is true, then R must be true as well. So what does that tell us here about if R, therefore P, then P, if R, then P? Well, that conditional, if R is true, remember, we're trying to make this true so we can get a line where all of these are true and this is false. Well, P must be true if R is true, okay? Now, what about here where we have R, therefore Q, if R, then Q? Again, Q must be true for the same reason as here. We can't have a true antecedent and a false consequent, and we know R is true. So Q is true. And what does that tell us about P and Q? P and Q must be true as well. And We're able to put all that together just by making S true, just by the fact that S must be true. And again, we've shown that this is a valid argument. There's no way that that these can be true and this can be false. It's a valid argument. Now, sometimes you're going to run into a situation where it takes a little more trial and error, a little bit of erasing and back and forth. Like, let's say we had tried to go about doing this by making the conclusion false for whatever reason. Say we made P false, okay? Well, that tells us that R must be false, right? R can't be true here and still make this true. So we make R false. That makes this true. That doesn't really tell us anything about the value of Q, but we can go over here. If S is materially equivalent, or it has this material biconditional sign with R, then we know that R must be false as well. Or sorry, if R has that material biconditional with S, then to make this true, if R is false, S must be false as well. So that's not going to work, right? That makes S false, and so again, we don't have a situation here, we don't have a counterexample where all of these are true and this is false. But there's other ways that this can be false. We also have to check the case where Q is false. And in this case, we'd run into pretty much the same situation. The fact that Q is false tells us that R must be false to make this true, which tells us again that S must be false. And then we don't have a counterexample. We don't have a situation where these are all true and this is false. And there's one more possibility we would have to try if we're taking this approach of trying to make this false first. That would be making both P and Q false. And that basically this works like the two possibilities that we just tried. We have R must be false, which would make S false. And again, that's not a counterexample. So you can see that if you go about it certain ways, it's going to take a little bit of trial and error. In some cases, that's the only way you can evaluate the sentence for validity, even using the short truth table method, is by a little bit of trial and error like that. But if you're systematic about it, it's going to get you the answer that you're looking for, and it's going to get it for you much more easier than using the full truth table method.